When I was a kid growing up in the 80s, one of the coolest science facts I learned was that Pluto and Neptune had recently switched in the order of the planets, placing Neptune farther away from the Sun than Pluto. They swapped back again in 1999, restoring the usual order and its associated mnemonics. I always thought this swap was neat, and I later learned that it occurs because their orbits have different shapes, with Pluto's orbit being more elliptical than Neptune's. But the diagrams showing this orbital crossover always bothered me because it looked like their orbits intersected. I know space is big, but the solar system is also old. How is it possible that these two planets have never collided, and why were astronomers not worried that they ever would collide? Well, it turns out that their orbits don't actually intersect because Pluto's orbit is tilted compared to the rest of the solar system. Let's examine how this makes a difference with our simulation. Here we have two planets, one with a fairly circular orbit and one with a very squished elliptical orbit. It doesn't take very many revolutions for them to collide with each other. But rotating the animation, we see that their orbits are in the same plane. They're flat compared with each other. On the other hand, if we tilt the elliptical orbit by just 17 degrees, the same amount that Pluto's orbit is tilted by, then the orbits form two interlocking rings that don't touch each other. The collision is avoided, and the gravitational force between the two planets doesn't even significantly impact their orbits like it did before. Next time, we'll add an asteroid belt to our planetary system and arrange for the computer to set up their orbits.